This video discusses programming for PrecisionTree. Specifically, it discusses the Excel Developer Kit, or XDK, for PrecisionTree and some of the ways this enables you to use VBA programming to build and manipulate decision trees. Actually, part of the PrecisionTree XDK also allows you to build and manipulate influence diagrams. But because the vast majority of PrecisionTree users focus entirely on decision trees, this is the only part of the PrecisionTree XDK that will be discussed here. The file you see here, PrecisionTree XDK Object Model Diagrams, illustrates the main PrecisionTree objects and the relationships, so I will use it to discuss the possibilities. Here is the PrecisionTree object model. Actually, this diagram shows only a few of the objects in the PrecisionTree XDK. For example, it shows the PT decision tree object, but it doesn't show node and branch objects. They are indeed part of the object model, and they will be discussed later in this video. As the explanation at the top indicates, you should first set references to ptree XLA and the PrecisionTree object library. To do this, you open the Visual Basic Editor with Alt F11. You open the References dialog box from the Tools menu, and you check the two items, ptree XLA and the object library. The role of the ptree XLA reference is that it provides a function, PrecisionTree, that returns the root object, also called PrecisionTree. Here's the root object, and here in the XLA is the PrecisionTree function. When you write PrecisionTree in VBA code, you are actually referencing the PrecisionTree function in the ptree XLA, but this accesses the root object implicitly. For example, the application settings sheet you see here indicates how you can use this root object to change PrecisionTree application settings, just as you can do manually through the Utilities menu. The sample code contains a simple macro that changes a few settings. You first reference PrecisionTree and then its application settings property to return a PT application settings object. Then you can change any settings you like. By the way, note that all of the formal names of PrecisionTree objects start with PT, but in this video I will refer to them less formally by omitting the PT prefix. As you are learning the PrecisionTree XDK, there are probably two primary things you will have to get used to. The more difficult of these, how to maneuver through nodes and branches of a decision tree, will be discussed shortly. The easier of the two, working with a model workbook and models, is discussed now. It is summarized in the model workbook sheet. Starting with the root PrecisionTree object, you can't get to a decision tree object directly. You must first reference the model workbook object. As its name implies, this object refers to a workbook, that is, an Excel file that contains at least one PrecisionTree model. When you use the model workbook property, you must specify the particular workbook as its argument. As this sample code indicates, the with block begins by specifying the model workbook. Its argument, this workbook, is a built-in Excel object. It always references the workbook that contains the VBA code. Often you can then proceed directly to the decision tree, as will be discussed shortly. However, it also helps to understand model objects and the collection of all models. A model is either a decision tree or an influence diagram. You can get to models through the models property, which references the collection of all models in a workbook, or through the models on worksheet method, followed by a specific worksheet reference, which references all models on this worksheet. Alternatively, you can get to all decision tree models with the decision trees property, and you could get to all influence diagram models with the influence diagrams property. The sample code illustrates some possibilities. After counting models, it checks whether each model is a decision tree model. Right here it checks, and if so, it captures the name of the tree in an array of tree names. Now we move to the key part of the PrecisionTree XDK, the part that deals with decision trees, how to create a new tree or how to modify an existing tree. As you know, a decision tree consists of a sequence of nodes and branches. In the same way that you can create these from left to right through the PrecisionTree user interface, you can build them hierarchically from top down with VBA code. First, look at the objects involved. Starting with the root PrecisionTree object, you first reference a model workbook, and then a particular decision tree from the collection of all decision trees. In particular, if you use the add method of the collection, you get the start of a new tree, the name of the tree, and a root node. It would look as follows. The rest of the object model lets you expand this tree by adding nodes and branches, labeling them, changing the node types, and supplying values and probabilities to branches. This involves the node and branch objects and their corresponding collections. There are a number of properties and methods of these objects, and it can be intimidating to maneuver through these to build the tree you want. But with the 3 guidelines listed here, the process is actually quite straightforward. First, a tree has a root node property, the node on the left, that is, the initial node in the tree. Second, any node has a child branches property, the collection of all branches emanating from this node. You can add to this collection to create as many branches as you need. Third, each branch has a destination node property, which references the node to its right. If you remember these 3 guidelines, building a tree with VBA code is reasonably straightforward. Let's examine the sample code required to build the simple tree you see here. This is taken from the example file PrecisionTree XDK creating tree 1. Actually, the code in this file not only builds the tree from scratch, but it also contains code to modify the existing tree in several ways. You can refer to the example file for more details. Here is the sample code that creates this tree. I'll walk you through the steps. Start by adding a decision tree to the model workbook. The tree will start in cell B2 of the active worksheet, and its name will be Simple Gamble. Moving to the root node, change its node type to a decision node, and change its label or name to Gamble ? Next, add a child branch to the root node. Label it Yes, and make it the first or the top branch. Then branch value cell.value specifies the payoff on this branch. In this case, it's a cost of 100 because of the minus sign. Next, move to the destination node of this Yes branch. Change its type to a chance node with label Win ? Then add 2 child branches labeled Yes and No. In each, branch selector cell.value specifies the probability on the branch, and again, branch value cell.value specifies the payoff. In this case, you win 5,000 with probability 0.2, and you lose 1,000 with probability 0.8. Finally, add a No branch to the root node, where you don't gamble. Its destination node can be left as an end node, with no gain and no loss. That's it. Obviously, it takes considerably more code to build a more complex tree, and you have to be careful about nesting the with blocks in just the right way. However, exactly the same ideas still work. In addition, the same ideas work for modifying an existing tree, and you can view sample code in the example file PrecisionTree creating tree 1 referenced earlier for making various modifications. Essentially, you start at the root node and maneuver through the tree to the nodes or branches you want to modify. Once you have a decision tree, it is easy to create a policy suggestion or risk profile report with VBA. This is illustrated in the reports sheet. From the model workbook object, you use either the new policy suggestion or new risk profile method. The sample code shows the details. For example, to get a policy suggestion report for the entire tree, you set the model by referencing a decision tree by its name. Then you use include properties to indicate what parts of the report you want, and finally you generate the report. If you want the policy suggestion report to include only a subtree of the entire tree, you can set the starting node property. The code for generating a risk profile report is very similar. As the code indicates, you typically want the risk profile for the optimal decision, which you can get through the Paths to Analyze property. The sensitivity analysis sheet illustrates how you can generate one or more sensitivity analyses from an existing tree. Now you use the new sensitivity analysis method of the model workbook object. This leads to a sensitivity analysis object, which has an inputs property for specifying the inputs for the analysis, and an output property for specifying the output, that is, the particular node's expected value you want to keep track of. The sample code provides several examples of how it all works. In the top analysis, the analysis type is a one-way analysis, and several properties specify the graphs desired. Then the output starting cell is set, in this case to the root node of the tree. Next, an input is added, and the properties indicate how it will be varied. And finally, the report is generated. The second analysis is very similar, except that the output starting node is an interior node of the tree, not the root node. The third analysis is also very similar. It is still a one-way analysis, but now there are multiple inputs. Then it makes sense to request tornado and spider graphs. Finally, the last analysis is a two-way analysis. In this case, there must be one input for the x-axis and another for the y-axis. There's the x-axis variable, there's the y-axis variable. Otherwise, the code is about the same as for a one-way analysis. Now that you have seen the basic features of PrecisionTree programming, you can take a look at the code in the PrecisionTree XDK example files. Specifically, the creating tree examples illustrate how more complex trees can be created and how the decision criterion can be changed to minimize expected value or maximize expected utility. There is also an example that illustrates how you can use PrecisionTree's Bayesian revision feature, new to version 6, to implement Bayes' rule by flipping a tree. After you study these examples, you should be able to mimic much of their code for your own purposes.